Good morning, Principles of Engineering. Today we're going to take a quick look at probability, just a quick 10-slide presentation for you, so nothing too long. Essentially what we're going to be doing here today is introducing enough information for you to complete your task. You'll notice on Shobi you have an assignment 4.1.1, which is data exploration, and that assignment is rather lengthy, so you're only going to be doing a portion of that today, so don't worry when you see how large it is, don't be intimidated by that. So, introduction to probability is the likelihood that a given event will occur. Okay, so the probability that I will roll a 3 on a die can be calculated simply by taking the number of outcomes I'm looking for, which in this case is 3, and that's one outcome. I'm looking for a 3. And how many outcomes are possible? Well, with a die, there are 6 sides. So if I roll the die, then there's a 1 in 6 chance, and that's the kind of thing that we're looking for, right? So if I'm really hoping for that 3, I should only expect to get it about 1/6 of the time. And so yeah, that's a very simple example, but we're going to be learning some equations that will help us calculate probabilities for more complicated situations. But today, just a quick introduction. So, methods for determining probability. I just kind of went through one very quickly, but we're gonna talk about how to do that specifically. So, the first would be empirical. In other words, we can simply observe what's happening around us, and then record those observations, and then calculate the probability. But yeah, so you can just do an example via an experiment. Of course, you could also do theoretical. And those could be things like, a coin toss or dice rolling and things like that. So typically empirical probabilities, you'd take that approach if it's a complicated system and it's really hard to, mathematically try to come up with a formula for calculating the probability. You might want to just go with the empirical observational approach. Whereas if it's a more simple system, theoretical makes it, it's not too bad, so you can just brute force calculate it. And then, of course, subjective, you can always just take guesses, but our intuition can be useful, but it is oftentimes limited, so of course we don't want to rely on that too much. All right, so what are the components of probability? Understanding the problem, trying to deconstruct this problem, right? So it has to be an activity with observable results. If we can't observe the results, then we can't calculate a probability. There has to be what we call a sample space, which is the set of all possible outcomes, okay? So if we go back to the dice roll, the sample space would be, the 1 through 6. The set of all possible outcomes for a single roll of the die, or the die, is 1, 2, 3, 4, 5, or 6. And so that is our sample space. So identifying that sample space, you have to know what the possibilities are, and you have to know what the result is. There has to be an event, which is the actual subset of the sample space. In other words, it is, say a single dice roll. And there has to be the result of the experiment itself. So what is the probability of a tossed coin landing heads up? So if I do the experiment, of course, I just actually flip that coin, right? Then the sample space would be the 2 possible outcomes, right? So there are only 2 in the case of a coin flip. It's either going to be heads or tails. The event is heads itself, and the outcome is basically the same thing, but we're actually looking at it there. So some redundancy there, but it gives you some understanding of what we mean by experiment, sample space, event, and the outcome. So a way of communicating the belief that an event will occur is basically a good understanding of what probability really is all about. Generally, we're going to express our probability as a fraction between 0 and 1. And of course, you're familiar with this from a percentage standpoint, right? So, if we see a 0.52 probability, then that's just like a 52% chance that it'll happen. So there's no mystery there. You guys should be very familiar with that. And of course, if we have the total probability for any sample space, will always be 1 because something's going to happen. So if I flip a coin, I know it has to be either heads or tails. So I can add up the two probabilities of heads and tails, 0.5 each, and I'm going to get 1 every time. So in the case of the dice, it would be 1 over 6 plus 1 over 6 plus 1 over 6, and you do that 6 times, and you get 6 over 6, so you get 1 once again. This is more relevant for you guys today especially, and that is the idea of relative frequency, okay? So what is relative frequency? Well, it's the number of times an event will occur divided by the number of opportunities for that event to occur. So we can define relative frequency right here as f of x, and that is equal to n sub x divided by n, where n sub x is the number of events with that outcome, and n is the total number of events, right? So if I were to use the coin as an example, then I would have a relative frequency of the number of times I got heads divided by the number of events. So for example, let's say I flip a coin 10 times, right? We would expect, if I were average, to have, say, 5 heads in 10 flips. But does it have to be 5 heads? Well, no, it could be 4, it could be 3, heck, sometimes it's even going to be 2, 1, or 0. But let's just suppose that I flip a coin 10 times and I got heads 4 times, right? So what's the relative frequency of heads? Well, the relative frequency of heads is the number of heads divided by the number of flips. Well, if I got 4 heads and I flipped the coin 10 times, then the relative frequency would be 4 over 10 or 0.4. And that's just a quick example, but it's pretty straightforward stuff, right? And again, this is going to be expressed as a number between 0 and 1 in the example I just said, 0.4. And the total frequency of all possible events, of course, will once again be 1, because if I flip the coin and I got 4 heads, that means I have 6 tails, and the relative frequency of tails would just be 0.6, which is 6 over 10. It's also 1 minus the relative frequency of heads. 1 minus 0.4 is 0.6. So you get the general idea. So probability, what is the probability of a tossed coin landing heads up? So I think we all know the answer to this, but that's the general idea, and we can kind of understand how probabilities are calculated by looking at the simple cases and then generalizing that to the more complicated cases. So how many desirable outcomes are there, and how many possible outcomes, right? Well, the desirable outcome is heads, and the possible outcome is heads or tails, right? So if I want to consider the probability, then I have to divide the desirable outcome by the possible outcome, right? So I have 1 desirable outcome of heads, and I have 2 possible outcomes of tails, and if I do the calculation of that, then I'm going to get the 1 divided by 2, and I'm going to get 0.5. So again, no surprise there. By the way, you can also express that, of course, as 50%. So we all know this, a coin flip is 50-50. So what's the probability of the coin landing tails up? Well, it's going to be 1 minus 0.5, which is also going to be 50%, right? So now this is interesting. It says, what is the probability of tossing a coin twice and it landing heads up both times? So this is a little less intuitive, but let's just, again, think of it the same way and see how it comes out, right? How many desirable outcomes are there? Well, or I'm sorry, how many possible outcomes are there? Well, I got to flip a coin, right? And after that, I got to flip the coin again. So that's what you're seeing here is I flip the coin once and suppose I get heads. Okay, well, now I have to flip it again. What am I going to get then? Well, obviously, I could get heads or tails. And over here, I could get heads or tails. So that's the outcome. But I'm only interested in how many of these paths, right? Well, I want heads up both times. Well, if I look carefully, obviously this path doesn't matter because I don't get heads at all. And in this path, I only have 1 of the 2 that matters. So there are a total of 4 possible paths, and I'm only interested in 1. So the probability here then would be the desirable outcome, which is 1 path, divided by the possible outcomes, which is 4 paths. And so we can go through and look at that, and yeah, we see the probability is 1/4, which is 25%. Another way to think about this is you look at the probability of the individual flips and then you multiply them. So in this case, I get, what's the probability that I'm going to get a heads? Well, it's 1 over 2. Well, what's the probability I'm going to get heads again? Well, I have to take my 1 over 2 and I have to multiply by 1 over 2, and then I get 1 over 4. And so if I want to know what's the probability that I get heads 4 times in a row, well, that's going to be 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2, right? And so that's going to be, what, 1 over 16. So you can kind of understand where that comes from, and then hopefully that made some sense to us, okay? And so it says, what's the probability of tossing a coin 3 times and it landing on heads 2 times? So that's interesting. So again, how can we understand this? By kind of breaking it down, right? So here's our first flip. We're either going to have heads or tails, but then we're going to have our second flip, heads or tails, and our third, or the second flip again in the case of the tails, of course, which is right here. And then we're going to have our third flip, and we're going to get heads or tails in each case. So we have all of these outcomes, right? But we need to know what is the probability of tossing it 3 times and getting 2 heads. Okay, so we need to look at each of these spaces, and we're only going to count the ones that have 2 heads, right? So here we have a row with 3 heads. That's not helpful. If we look down here, we could go heads, heads, tails. There's 1. Here we go heads, tails, heads. There's 2. Here we go heads, tails, tails. That's not what we want, so that's still 2. Okay, so far we've gone through half of it and we've got 2. If we go back here, this path is useful. There's 3. If we go here, this path, not so useful. And if we go down here, we'll notice that these are not useful either because they both have 2 tails. So we have 3 desirable outcomes, right? So 3 desirable outcomes. How many possible outcomes? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So if we just take that and we divide, we will get a total probability of 0.375, 37.5% probability that we have exactly 2, I can read. The probability is going to land on heads 2 times out of 3 tosses. Okay, so believe it or not, that is it for today. We're just looking at this idea of sample space, of probability, and of relative frequency. Hope this made some sense to you guys, and you should now be able to complete procedures 1 through 4 part D, which is all I'm asking you to do today. This will require you to mostly record data because you're going to be flipping coins a lot, and then we're going to analyze that data in a little bit more depth later on. So hope this was helpful, guys. Take care.